no complaints. And getting 14 is pretty amazing.
Great. And I think we're live. We will give people a few seconds here to trickle in, but here with Charles Yeomans from Atombeam. Really excited for your time and this Ask Me Anything. So we'll wait maybe 30 seconds or so to get some live viewers, and then we can get started. And we'll take some initial questions we have, as well as some live questions from the audience. Give it another 10 seconds or so and then get going.
Right. Good to be here. And I'm, happy to get a chance to talk to my audience. It's, the community we've built here is pretty great. There's a lot of people have started, more than started, a lot of people are really digging in and really understand it pretty well, what we do and how, big a deal this really could be. So I appreciate all the attention and everything. I think it's warranted. It's pretty exciting, but very happy to be here and get a chance to answer some questions. It's kind of like being the president or something. You get out and talk to, answer questions. That's sort of fun, right? So
in front of the press, right? I think it's so powerful for investors to be able to hear from you directly and ask you the questions that are on their mind as they're maybe making that final decision about investing. So we can jump into things, but thank you everyone for joining. We're here with the final Ask Me Anything with Atombeam CEO, Charles Yeomans. Charles, appreciate the time. Just to bring everyone up to speed, Atombeam has just crossed 14 million raised this morning in their current live offering. Almost 3 million of that has actually come in the last 7 days. So with this massive amount of momentum, we're going into their final day of the offering. It's closing tomorrow, the 18th at 11:59 Pacific time. And their previous rounds leading up to this one actually sold out with over $3.6 million on the wait list. So welcome, Charles. This is your chance to ask Charles any questions you have about Atombeam, about their funding round before it closes tomorrow at midnight Pacific time. Please ask your questions in the chat. Charles will be answering these live. If we don't have time to get to all of your questions, you're welcome to go to the Atombeam campaign page and add your questions there, which Charles, I'm sure, will be very busy fielding a lot of those questions in the next 12 to 24 hours or so. And we will also be sharing this video with all attendees after the webinar is over. So without further ado, we'll jump into a few initial questions we have, Charles, and then take some live ones from the audience as well. Just to start off, who are Atombeam's current customers and who do you see as future customers?
Right, yeah. So right now, all of our live actually paying us customers are all DoD. That is to say, it's the Space Force and the Air Force. But I anticipate that some pretty soon, due in part to some pretty important partnerships that are inked and all that, that we are going to be seeing some probably Q1. I would certainly expect, because we're in the middle of pilots. In various cases that we're going to start seeing through Viasat, through Ericsson, through potentially NVIDIA and Intel and HPE, our various relationships that are formal, inked on the piece of paper relationships. That is what we see as our primary sales force going forward. So in other words, like there's a 12 billion packaging company that is about to start a pilot with us, and it's a European company. We just were over there talking to them, it was last week, and that they were excited about it. They want to move forward. They had 20 people in the room, and it was a very successful discussion. But those are sort of the big honking ones that I think are going to be not the exception, but it's like one way we go about it. The other way we're going to go about it, and I'd see it as potentially the biggest volume, is through the partnerships. So Ericsson says, I have a gateway that now is able to send 4 times more data than before, and send 4 times more data than the competition for IoT gateways. So they're very excited about it. As they said, and they've said it several times, we normally don't partner with companies that are as small and early as Atombeam, but we think this could be a pretty important opportunity. And from their perspective, it's an opportunity for them to sell more boxes. You know, it's fine if Atombeam makes money too. That's fine with them, but they want to sell more gateways. How do they do it? Our gateways send 4 times more data than Joe Blow's. That means they're going to sell more gateways. And so that's an example. And Viasat is a very similar sort of calculation. So we just did a webinar with Ericsson a couple of weeks ago, or when was it? No, maybe it was last week. God, got to tell you. And we have another one that's getting on the books with Viasat and in February. And these guys don't do this kind of thing unless they really believe you have real product that really works, and there's a country mile between product and a science experiment that works in a prototype. This is real stuff, and it's hard to do, and we have the kind of people now that we can do it. So long answer, but the short answer is right now it's DoD. That's looking really good to expand next year, but also through these partnerships and through direct relationships with big companies. I think next year we're really going to start pushing out the significant amount of commercial revenue.
That's great. Thank you. I'm sure you get asked by AI and talk about AI almost every day, but there's a very pertinent question from David M. Atombeam is a data compression company, but it seems like you were trying to ride the AI coattails a bit too much for my comfort. Can you dissuade me from this outlook? And I think within that answer, would love to hear your thoughts on how the rise of AI has benefited Atombeam and will continue to benefit you guys in the future.
No, that's a fair question. So it's a little complicated because there's different pieces to it. So one is like when you just take NERPAC, which is our current release product, that isn't really, well, you could formally call it AI, but it's really a machine learning kind of thing that we use in it. What it's doing is it's looking at a big chunk of sample data and looking for patterns that repeat a lot. And it builds a code book doing that with machine learning. However, you know, in terms of like when you think about what AI typically is, it's not really that. However, we have 2 other products that are in the works that are real neural net AI. One of those is called NCOM. NCOM is basically it's under a contract with the Air Force right now that they are pushing us like crazy to hurry up, get it done quicker and everything. Those guys, you know, want to see us expand to a lot of different kinds of sensor generated images. Right now, we've been working on what's called synthetic aperture radar images, which are images that are taken if you have a satellite transiting over the Earth and firing a radar at the object, it can build a picture. But those pictures are big, and how do you send them to the Earth, which is where they need to be used, is an issue because they're big. So standard kinds of compression, you know, are okay, but what we can do is we can take an off-the-shelf video codec, which are really efficient, and we can enhance its capabilities using this neural net AI that is the fundamental NCOM thing. So that means NCOM can, you know, it looks like it does about 2 times better than an off-the-shelf compressor like JPEG 2000, which is a state-of-the-art compressor. So that's real AI. And then the other big AI thing that we have that's also in development is called the lightweight code word model, the LCM. And the LCM is a new kind of generative AI that takes advantage of the more informationally dense data that NERPAC and NCOM generate to substitute that for the language you get in a large language model. So instead of this much less informationally dense English or versions of things, or that are basically language. Instead, we're packing it down so that on average, NERPAC gets 75% reduction. So 75% smaller in terms of the same amount of information means that you can make AIs, that is to say, in the case of LCM, the LCM can be 75% more dense, which means we can skip some layers of the neural net, which means, in essence, that we can do with a lot less computing the same thing an LLM is. And so far, and this is preliminary and all that, but so far we're looking like we save about 25% of the power use, which is a huge deal. And the last thing to mention here is, going back to NERPAC, is NERPAC can be, although it's not formally using a neural net, it is a way that AI can be a lot more efficient. For example, one of the big things is the plumbing, which is what Wall Street Journal calls it, is the big limiting factor right now for AI, because in data centers generally, because you need to send all this data around, data replication, data moving between chips, between servers, and also one of the big things is between AI and AI agents. There's tons of data that has to move back and forth. I'm working with a big company right now on just this. How do you access data back and forth really, really fast if you're an AI agent talking to the core AI? That is a big question, and we think we can do a lot to solve it. Now, I'm not saying we have a product that's out there and works right now and all that, but there's no reason why NERPAC couldn't do that.
Great. You mentioned a few of your products, NERPAC and NERCOM being two, and we had a specific question from Ed Z on NERCOM and when that will be developed as a product, what the specific timeline for it looks like.
Yeah. So a lot of that depends on, it's two factors. One is we need to hire different kinds of people than we have, because those doing that, so that kind of approach, that is, this is a kind of really exotic kind of AI. We need specific kinds of developers who know that kind of stuff and would work on it. So that's one factor. The other factor, and I'll get to the timeline here, but the other factor is we'd like to have the government pay for that. And they say they want to. So first we have to, we're going to pursue it, but next year for sure. And it's only a question of how many people we want to hire and how much we want to spend to get it out there, absent government funding. I think, but I should add that the Air Force Research Laboratory has told us, if we can continue to make the progress we're making under the contract we have, they want to move it into a phase 3, which is basically the getting ready to deploy it phase. And that typical phase 3s are 10 million kind of size, maybe even 20, depends on what they want to see us do and so forth. But they have said, again, they would like to do that, and that would be in fiscal 26, which starts in October. So in terms of productization, if we had all the money in the world, we'd productize it right now. But it's a question of priorities and where we spend the money and all that. But
it's always capital constraints.
Yeah, it is possible we get it productized sufficiently to push it out next year. It does work, but it's not a product in the sense that you could hand it over to someone and they would just use it, which is where we need to be.
And as you mentioned in your previous answer, you guys are really working directly with neural nets and directly on what we're considering AI now, as opposed to being more tangential to AI, and hiring those personnel, those capital requirements are quite extensive, as you know.
Yeah, right. Yeah, no, that's exactly right. I mean, there's what what we do is in many ways an enhancement to things. So instead of, instead of, Ericsson selling, the gateways that have the same capability as other gateways, maybe they're fancier and they have extra cool software or whatever, but they're not fundamentally different in terms of the output, the fundamental product. Now they are. And that's the thing that we do overall. I mean, we improve things rather than are the final solution thing.
Understood. I think that's a helpful summation. We have a question from Indigo C. What do you see? Who do you see as your biggest competitor? What is your moat? I've seen some other companies promising data transmission over 10x what an NVIDIA chip can do.
Right. So, okay, yeah. So biggest competitor, that's always a problem for us because, it's not really compression. You could sort of say, okay, it's compression companies, I guess, but compression really doesn't work on IoT for the most part. I mean, when you get really pretty big datagrams, which is larger than the standard datagram you get with IoT, then yeah, you could say, okay, we compete with it. But the net is you don't really see people using compression on IoT unless they're willing to what's called batch. That is to say, wait until you have accumulated enough data, and then you can use compression on it because it won't work on the little datagrams. And then you batch it and compress it and send it. But you're adding a lot of latency. You might add 5 minutes, you might add a day. And so we really don't see much in the way of real competition. I mean, it's so different than compression. I mean, and the other thing is too, is that with NURPAC, we are able to not only reduce the size of it on average 75%, which, yeah, okay, say compression can do that for the bigger datagrams, but they're not able to do two other things that are crucial that we can do. One is just by the algorithmic structure, we are not like working on finding in an individual little IoT message repetitions of pattern in that message and replacing the repetition with a little placeholder that says put that back when you reinflate it. Instead, we're taking out the whole contents of the message and replacing it with little code words that represent the patterns in the message. Consequence of that means that if a server has the codebook loaded into RAM, it can look at an entire data lake that was encoded with that codebook, and it can see it, it can view it, it can use it. It's called homomorphic. That's a formal term, but it isn't quite that, because what it's doing is our algorithm is so fast that it can decode and encode in a few millionths of a second, which means that computer is effectively looking at the original data. And that opens eyes if you're talking to engineers. They really understand, because a data center's huge problem of trying to find the data you want, because most of it's all compressed and you're looking at the little tags on them that say, okay, that's what's in here, but it's not the same thing as seeing what's in there. So that's a huge deal. And the other big deal that we are submitting a paper to IEEE, one of their publications, which is the big thing for engineers, a mathematical proof that shows that in a modified version of NURPAC, we can also encrypt at the same time we are what we call compacting it. So not only could you, because it's so light and small and fast, you could on anything, a temperature sensor, a washing machine, a nuclear missile, any of those things can have NURPAC in it and can encode and encrypt the data and compact it at the same time. So give you four times more bandwidth in effect. And it's encrypted from the edge. 98% of IoT data has no security at all, which is a huge problem. And so you think about the implications of that. You got this thing on the edge, which like whatever, the temperature sensor, your phone, whatever, sending data, but the sending data, instead of sending it in the clear, unencrypted, it's encrypting it and it's reducing the size of it. So you can send 4 times more of it. It gets to the data center, and the data center just can store it. It doesn't have to compress it, decompress it, and decrypt it or anything. It just stores it. It can be stored in encrypted and compacted form, which means that you can squash it down that much and you can use it and randomly access it and all that stuff. And that is, it's really significant. So somebody steals it, some of your data. Okay, it's encrypted. They can't use it. They randomly access. The reason why Snowflake and Databricks are worth so much is because they can use the data at rest. They have AI that is complicated and everything. Ours is much simpler. You can just see what it is. So anyway, so it's fundamentally a change to how everything could work in the future. So when you say who the competitor is, we really don't. There's nobody else that does anything like this. I mean, yeah, there's a compressing company. There's those, but it's kind of like, okay, that's one thing, but it's not. It's a long way from everything. And in the moat here is, I think it's, the count is right now is 77 issued or allowed patents and another 103 that are pending. It's formidable.
IP moat.
Formidable. And these are really good patents. We've had them poked and prodded by some pretty heavy duty law firms, and they agree. So I'm pretty confident about our moat. And so, I've seen some company promising data transmission over 10 times what's on an NVIDIA chip. I'm not really sure quite what that means, because NVIDIA is partnered with us, and there's very, very high levels there that are interested in what we do because they can't do it. So maybe that addresses that question.
Yeah, that's really helpful. Thanks, Charles. And maybe just pushing on competitors a little more. You mentioned it's hard to sort of describe or qualify a direct competitor of you guys, given what you're doing in compression is so unique. A question from Johan G. How does Atombeam differ from Palantir? And maybe, do you view them as a competitor? Do you view them as being tangential to what you're doing? How would you contextualize that for everyone?
Yeah, I mean, no, I mean, I've dealt with the CTO of Palantir. He really likes our stuff. And, for reasons that are basically, he's busy and I'm busy, we haven't pursued it. But no, they're not a competitor at all. Think about what they do. They do a lot of things, right? But one of the core things they do is take in data from tons of sources, mash it together using AI to make a battlefield picture that is clear and is taking in data from a satellite, from a drone, from some sensor on the ground, whatever, and it's pulling those things together and creating a picture with AI. Well, guess what? There's lots of data flowing into this thing, and also you want to have it encrypted. So, I mean, it's kind of like he said, well, what's not to like? I mean, it was like, okay, if I can get 4 times more data, I can make a better picture. And if I can get it secure at the same time, and if I can store it and not have to have it compressed so it's harder to find, or to have to be decompressed, it's great. I mean, he loved it. So no, Palantir is a prospective partner. I mean, it's just bandwidth that we haven't done anything. That's it.
Mm-hmm. That's helpful. Reminder to everyone listening and watching, ask questions in the chat and we can have Charles address them live. We have a follow-up question from Jerry L. on NCOM development, specifically, how well built and tested is zero-touch provisioning? He mentions this comes into play for large-scale initial deployments of several thousand gateways.
Yeah, I mean, so on NCOM, I don't want to advertise that as being deployed, as being ready to be deployed. It's not a product yet. Will that be something we do? Absolutely. That is what you're talking about there is, yes, we want zero touch provisioning. We want to be able to just push a button and have it go out there. That is what we can do right now. It's not zero touch, but it's really, really low, and it's under 2 minutes, but it needs to be zero. And I totally agree. And so do the development guys. We have to have, something that is simple, and it automatically figures out everything. Longer term, where we really want to be is we want to be in chips, so that instead of having a container sitting on like a gateway, it would be on a chip in the board of the gadget, of the gateway or whatever. That gives us the capacity and potential to be able to address literally billions of things. And if we can address billions of things, then that changes the world. I mean, that means that, you buy a temperature sensor for your smart building and stick it up on the wall. It's got us in it and already. And the same is true with a Palantir, source, a Samsung smartwatch, a whatever you want to name. All those things need to have a chip, and that's how we get big. But and also it goes to the zero touch, right? It's already there. You don't even know it's there. All you know is this seems faster than it was. And also, by the way, if you're sending less data, it saves battery power and power generally. So if you're doing that, your battery lasts longer. That's why Samsung was interested in talking to us about, they wanted to send more data back and forth from their wearables, but they also see it as an opportunity to extend battery life, which is always a big question with smartwatches and so forth.
It's an interesting future goal of being on chips. You talk about Mark R asked a related question. What are the highlights you're focused on for the 2025 roadmap? Does what you just mentioned, being on chips, is that one of those? What are some of the other highlights? And what can investors expect going forward in regards to updates and calls?
Yeah. So, I'm happy to have at least quarterly calls, and do a quick catch up. Here's where we are and what we've done and where we're going, and take questions. So I'll say that, yeah, absolutely. Quarterly is good. On the what was the other question? Sorry.
What can around 2025 roadmap,
Oh,
and what are some
2025,
of the
yeah.
highlights of
Yeah.
next year that you're focused on?
I think that what we want to do next year is really it's going to depend on how much money, right? But given where we are right now, what we're focused on is getting the 2025. I'm sorry, in 2025, doing some certain feature releases to NERPAC, the current release product, to make it into, even more efficient, even better. When we go out and talk to these big companies, but they have specific requests. They want us to be in Azure. We're only in AWS right now. They want us to be able to release the security encryption feature. We haven't done, that is prototyped, but needs to get into the product. How do we make it faster? How do we do things to the core code to make it more simpler to upgrade? There's all these things that these really, really knowledgeable guys we have do to say, okay, this code is too much. It's too complicated to upgrade this feature. I want to make it simpler and clearer and click. And it's the guts of it. And so that on the development of NERPAC, we'd like to be able to develop and release early versions of the LCM and of NERCOM. I don't know if we're going to get there yet, because it depends, again, on how much resource we have. It could be the government puts up money for both. And then on sort of like on business goals, like in Q1, we want to sign some POs and really start to get revenue rolling. It'll be early. Stuff will be, smaller because, okay, we were just talking to an oil company, they have 3 million nodes, which means endpoints that we could charge for. And they're not going to do a pilot and then hand over 3 million nodes. What they're going to do is say, well, we really need it over here. So let's give you 100 or 200 nodes to start with and see how you do. And then we'll move it to a wider spectrum after that, and so forth and so on. So most of that the early stuff will be small, but then by mid-year, we should have the code being in NERPAC being more efficient and easier to deploy and easier to this. And not that it's hard at all, it's really easy. But that and pushing on developing our distributor relationships. We have a distributor in Saudi Arabia and another in Japan. They both have very specific things they want to do right now that they're pushing hard because they need this, they need that. And we're talking about major league companies that they have relationships with. We also have a number of chip companies that want to work with us. Specifically, because NERPAC is so light and small, it can move data on between chips on a board and even within a chip faster. And it's all, where the limiting things are right now for moving data around is the big limiting factor. And we can address that. And so there's no end of companies. I mean, what companies use a lot of data? All of them, So, focusing on that commercial development. And finally, on the DoD, we have a big push on there. I was just at a conference, or kind of a summit thing, because there were a lot of admirals, with Admiral Becker, who is on our board. He's a retired admiral. He ran all of the Navy's communications. He was a 2-star in charge of something called NAVWAR, the Naval Information Warfare Systems Command. And there are a couple of programs. One is drone swarms, and the other is something called Link 16, which is the ubiquitous communications, data communications that NATO and allies all have. They need it to go faster. And based on early results, we can probably get 7-8 times more data. And they're desperate to do something. So that could turn into something. So there's a lot of activity here that we think could turn into something pretty heavy, pretty important, both in terms of developing, releasing product, doing more in DoD, and getting commercial revenue really rolling. And so I expect commercial revenue by mid-year to be really, really pushing along nicely.
Great. It sounds like a really compelling roadmap for 2025. And I know we're coming up on time here, so we'll take one more question, Charles, then wrap things up. Question from Renewables for Earth. Congrats on going over 14 million. Have you made a decision on extending or not extending the raise?
Yeah, it's a fair question. I mean, no, we haven't. We're kind of seeing how it goes between now and tomorrow morning. We do have an internal goal to get to 20 mil. And so that is really, it's really important for us to do that. But at the same time, part of it is we don't want to tell people something and then do something else. And that's a struggle for us, because I always try to do what I say I'm going to do. That being said, there's a lot of people pushing me and the company and asking for us to extension, to extend it. Because January, a lot of people get their bonuses or the taxes and all this stuff. So, and we do have this compelling need for, really getting to 20 million because of all the huge number of things that we have going on. So there's a lot going on, and there's a good reason to do it. But that being said, we really want to think hard about it and see what happens over the next 24 or so.
Well, thank you. It's helpful to get your thoughts there, Charles, and thanks for the time. Thanks for everyone to joining. As of now, Atombeam closing tomorrow at midnight Pacific. We will be resharing this Ask Me Anything on several channels. And if you have further questions that we didn't get to, feel free to ask those directly on Atombeam's campaign page. But thank you, Charles, for the time.
Sure. Yeah. I'm sorry I was so long-winded to not be able to get to them all. But yeah, feel free, post them in the discussion section. And I try to be good about responding to those within a day. and I'll try to be faster here for given the constraints. Okay, well, very good. Well, thanks everybody. Thanks to the Atombeam community and our investors, and you're the guys who provide us the rocket fuel, and we know it and appreciate it, and everybody in the company knows it and appreciates it. So thank you.
Thanks, everyone.